So now that we're able to generate such JSON Web Tokens, let's, as a next step, use them to implement route protection, to make sure that certain routes only answer with a success response if the request was sent by a client that has a valid authentication token. Now, in our application here, we at the moment have 3 routes that should be protected and that should not be accessible by everyone. And that's the route for creating new events, for updating an event, or for deleting an event. And I will start with the create event route. Therefore, we can go to Events Go, and there to the create event handler function here. And it's now here inside of this function where I now essentially want to take a look at the incoming request and check whether it contains a valid token. Therefore, in here, before we do anything else, we should extract that token from the incoming request, which we can do with help of this context value. And there we can take a look at the request, and I expect the token to be part of the request headers. So we can dive into the headers that are part of the incoming request, and then there call the get method to get the value of a specific header that is attached to the request. Because my idea here is that the clients that do send requests to such protected routes will have to attach such a valid token as part of their request headers. Specifically as a value for the authorization header, which is a header that's commonly used for transferring such tokens. So I'm taking a look at this specific request header, to be precise at the value of that header, and that then is that token that was sent by the client. Now, of course, it's possible that the client didn't send anything, and therefore we should check if the token is equal to an empty string. Because get will always return a string, because the header values will always be strings, and if it's an empty string, that simply means that no token was part of the incoming request. And in that case, I of course wanna stop executing this function, and I definitely don't wanna move on to the next lines. Because this should be a protected route, a protected function therefore you could say, and it should only be executed if we got a valid token. And if we got no token, that's of course not valid. Therefore here in this case, I'll send back a response with a status code of unauthorized, so this 401 status code. And then again, I'll create that map where I also send back a message where I say not authorized. And thereafter I return so that no other code gets executed. Now, of course, it is possible that we do have a token, so that we don't have an empty string, but that it's not a valid token, that it's instead an invalid token. And therefore, we should check for that as well. Hence, I'll go to the jwt.go file in the utils folder, and in there add another function, which I'll name verify token. The name, of course, is up to you. This function should get the token as an input, as a parameter, and then in there we want to verify that token. Now for this, the JWT package, which we also used for generating the token, also offers a useful parse method, which parses a received token and in the end extracts the information that's stored in that token, and that also tells us whether it's a valid token. Now parse wants that token as a first input value, so I'll pass that as a value here. And then it wants a function which job in the end is to return the secret key that we used for signing the token. So therefore here I'll pass an anonymous function to parse, and that function will automatically receive the token, though not my token here, but instead this function here will be called by the JWT package, and it will receive a value of type JWT token, so that built-in token type that's provided by the package. And to be precise, it will be a pointer to such a value that will be received by that function. And this function then will also return two values. It will return the secret key, which could be of any type. Hence, I'll use this AnyType type here that's built into Go. Or we may return an error. And then I have opening and closing curly braces that belong to this anonymous function. So in here, we now should return the secret. So in its simplest form, we can of course simply return this secret key constant, which we used for signing, and nil for the error. However, you should also perform one extra step in there. You should check whether the token that you're verifying was signed with that signing method you chose for creating it. So therefore in here, you should use that token, so this token here, which is passed in by the JWT package, and access the method field on that token value. And now we can use a special syntax that's supported by Go to check the type of this value that's stored in that field by adding a dot after that field, and then between parentheses, you pass the type for which you want to check here. So in my case here, I want to check whether the type of the method here is a pointer to JWT dot and then signing method HMAC. Because the signing method I used here is in the end a version of this type here, of this signing method HMAC. Now when using this special syntax here, we'll actually get back two values where I only care about the second value. The first value here would in the end be the value that's stored under that method field, which is expected to be of that type. But I don't care about that data. Instead, the second value that will be returned by this special syntax here, so by this type checking syntax here, will be a boolean that's true if the value stored in the method field is of that type and false otherwise. Therefore, I can then check if not okay, so if the method that was used for signing the token is a different method and not the method we used in the end. So if that's the case, I of course want to return an error, because in that case the token is definitely not valid. So therefore here in this inner anonymous function here, I'll return nil for the secret key because we got an invalid token, so I definitely don't want to share my secret key. And instead I'll create a new error in here with the errors package and say unexpected signing method, for example. This check might be a bit strange, but it is recommended that you perform it to make sure that the token you received really was signed with the method that was used for signing. And this special syntax here is now not token or JWT package specific, but instead this is a type checking syntax where you can access a type like a property with such a dot on a field to check if the value stored in that field is of that type. And with that, we're done with this inner anonymous function. JWT parse will then, as a result, return a pointer to the parsed token or an error if something went wrong. So we got a token or an error, and that is the parsed token. So let's maybe use that name since I'm using token in a couple of places already. And therefore now here in the next line, we can check if the error is not equal to nil. So if something went wrong there. And if the error is not equal to nil, I want to return it. So here I will actually return an error from verify token, and I'll return a new error here. Could not parse token could be the error. Now, after checking for that, we should have the parsed token, and we can now extract some data from that token and also find out if it is a valid token that was signed with our secret key, which we returned here. Therefore, as a next step, I'll use that parsed token And as a first step, I will check the valid field on that token. As you see, that is a boolean that is simply true if it's a valid token and false if it's not. So if it was not signed with that secret key we used on the server. So therefore here we'll get our token is valid variable, and we can check if not token is valid, in which case I of course also want to return an error. So here I'll return a new error where I say invalid token. Now if we got a valid token, we can use our parsed token and access the claims field to get hold of the data that was stored in that token. So the email and user ID field. Now this claims field stores a value of type JWT claims, and we use the more specific map claims type that is provided by the JWT package. Therefore, what we can do down here is again use this type checking syntax here, which we already used before, where we add a dot and then parentheses. And then here I want to check whether the claims we got for this token is of the JWT map claims type, which it should be if it's our token, because we used that type, that map claims type, for including our data into the token. As a result, we'll get back the claims and again this OK variable, which is a boolean still. And claims is now of this more specific map claims type because Go understands that if this check succeeds, it has to be of that more specific type because we're checking for this more specific type here. Therefore, we can of course now again check if not OK. And in that case, again, return an error where we say invalid token claims or something like this. But after this if check, we now will be able to access the data in that claims variable here. And here we now got this map claims type exposed by the JWT package, which under the hood in the end is essentially a map. So we can use square brackets to, for example, get hold of the value stored under the email key. And here I am using the keys which I used up here for storing data. So email and user ID. These are the two keys I'm interested here. So here I got the email like this. And then I got the user ID by accessing user ID. Now, if you hover over email and user ID, you see that at the moment Go doesn't really know which exact data type it is. It could be any data type. And therefore, what we should do here is again use this type checking syntax here and check whether email is of type string. Now we could also again extract the OK value and check whether it's not OK, but here we know that at this point where we have a token that was created with the correct signing method and that we identified as being valid, and where we have the correct claims, that the claim data will be in the right format because it's definitely the token we created up here. Therefore down here, I actually won't care about the OK value, and instead I'll just use that here to in the end tell Golang that email will be of type string. And for a user ID, it's an int64 value, and therefore we can use this syntax here. And now here in the end, after all these steps, we know that we have a valid token. At the moment, I don't actually care about the email address and user ID yet. I just wanted to show you how it can be extracted, but I'll comment out all this code for now. And instead, I'll simply return nil. So no error, since the verification worked. And that is now the finished verify token function, which we can now use in the events Go file to make sure that we got a valid token.